Hello, my name is Anranigam and I'm going to present today how to model a quadrature phase no lead pack for ICs, right? Using EM Pro. So how do we do that? First of all, look for the QFN. So I'm going to go to QP Technologies, which is also earlier known as Quick Pack, right? And from here, I'm going to choose one of the package. So if I go to products, I can choose. So this would be called a QFN. So I'm going to model a QFN like that. I'll go to OMPP. So these can be used up to 40 gigahertz, right? So I'm going to choose one of the drawings here. So let's say I want a 5 millimeter by 5 millimeter, right? And I want the interior pedestal. So call the interior pedestal where your chip is gonna sit. So I want that one to be 4 by 4 mm. So if I choose the outer diameter to be let's say 6, and then it is 0.65 as the borders, so probably I will uh, have here 4.3. So you can see here this basically shows you. So let me just zoom it. Okay, so the pedestal here is going to be 4.34 mm square, right? So your IC can sit here, right? And there are 28 leads here, right? And if you see the cross-sectional view, you will see that the outer dimensions are are here 6 mm, right? So this is 6 mm, right? And then the pocket basically is going to be 5.54 mm. But then if you go down, like it's at an angle of 12 degrees, right? So if you see this one, if I zoom further, okay, so you can see that this is at an angle of 12 degrees here, right? So if this one is 5.5 point, where is it? I just read. Okay, so this dimension is 5.3, and then when you go up, uh, this dimension is 5.54, right? So it is at an angle of 12 degrees here, right? And then this one, the pedestal, the height from the bottom is going to be 2.23 mm, and you can almost see here. So they have shown this one. This is a ground plane here, and then there is this gap, right? So the pedestal is 4.34, and on the lower side is 4.14, right? And the pins over here, okay, so the pins over here, 5.24, right? So you need to minus from 6 5.24, so that will be 0.76. Okay, so 0.76 for 2 pins, right? So half of that, right? So that would be 3.38, right? So 0.38 is the lower, and then on top of it, this is going to extend. So this is 4.64, right? So 4.64 from 6. So 6 minus 4.64, that will be equal to 1.36, right? So 1.36 divided by 2, right? 2.6 uh, 1.68, right? So basically the length of the pin is 0.68, and the lower side of the pin is going to be 0.38 long. So that's how these pins are going to be there. So we have to make a geometry like this, right? Ultimately we are going to have a geometry which is going to be like this. So let's go ahead and start drafting this in EM Pro. So when you open EM Pro, you have to go to generic FEM in millimeter. You can set the minimum to maximum frequency from 0 to 40 gigahertz, right? And you are done. You can cancel this tip, and these are your views, right? So I'm going to look everything on the top view, right? And let's get started. So I'm going to first save this. So I'm going to save project, and I'm going to call this as QP 6mm. Okay, QP 6mm is the Quick Pack 6mm QFN, right? So here I will put QFN also in case you going to have more packages. So once you do this saving, then I'm going to draw this with the origin at 0, 0, right? So the dimensions are going to be in mm, right? And if you see the drawing, all the dimensions are in mm. So let me just fit it 100%. So it mentions here the dimensions are millimeter, right? So all the dimensions are in millimeter. So let's go ahead and draw this, right? So I need a pedestal which goes 0.263 as the total, 0.263 0.203 as the height, and 6 mm by 6 mm is the dimension, right? So I will go here and draw that. So this is extrude, and I am going to draw a square which will go from 0, 0 region, and then you can press a tab and you can put here 6 mm by 6 mm. So that's the dimension I'm going to put here, 6 mm by 6 mm. Okay, so the entire QFN is going to be here, and if I'm going to extrude this, so I will call this as base, or base 1. So I'll call this base 1, and I will extrude this to 0.206, right? And say done. So I have drawn that 0.06 height, the bottom part of it, right? Next, what I'm going to do is, okay, so I'm going to draw all the pins and the pedestal in this, right? So let me view this. Now let me know the dimensions of the metal, right? So the metal total height is 0.203, but then there is no information on this height. So let me tell you what you mean by that. Okay, so this bottom portion is divided into two heights, right? I'm assuming half of it, because if I don't assume half of it, there is no information on what is the height of this, right? So what I'm going to do is I am going to go later, and I'm going to say I want 0.203 divided by 2. Okay, so right now this is 0.102. So let's say I take 0.0102 as the bottom portion, 0.102, right? So I'll go here, and then this dimension is 5 point. So this dimension is 4.34, right? So 4.34. So let's go to calculator, and we have 4.34 as the dimension of the ground pedestal, right? So I'm going to just divide, well, not divide, I have to subtract from 6. So roughly that divided by 2. So yeah, So then I have to leave 3.32 mm, right? So let's do, come on, cancel. So this is 6 minus 4.4 by 2, right? So 0.83. So I have to start from 0.83 my pedestal, 0.383 by 0.83. So I'll go here and okay. Another thing you need to see here is that the lower dimensions is 0.414, right? 0.414. So let me go to calculator. 0.414, right? Okay, clear this. 6 minus 0.414. Is that correct? Not 4. 41. Okay, 0.414, right? 4.14, sorry. So 6 minus 0.14. So this one divided by 2, 0.93. Okay, so 0.93, 0.93. Right, so that's how I will draw it. So here I will go ahead and say I want to put a tab here, and I would say here 0.3, okay, and 0.93, and that's my origin. And so I'm drawing the ground on the bottom side, and then tab again. 4.14 is the total dimension. Correct. So that's there, and I'll extrude this to a height of 0.203, right? 0.020. So I'll take 0.206. Let me just check it. 0.203. So there is a height issue here. Okay. I did a mistake on the previous one, but I'll correct it. Okay, so I'll go to 103. 102, sorry. 2. And 101. Okay, fine. So I'll extrude by that, and I'll call this as GND1. Okay, so this is on the back side of it. So that will be the ground pedestal, and I have to shrink the size of this base one. So if I go to modeling sequence and extrude, I can fix this to be 0.03. Done. Okay, so that part is done. So that's the bottom part. Okay. Next thing I'm going to do is there are two different heights of the ground. So if you go here, so the top one is 0.434, right? 0.434. So I'll go to calculator, cancel it. I'll say 6 minus 0.4, sorry, 4.34, right? 6 minus 4.34. Am I right? 4.34 will be equal to this divided by 2. So 0.83 and 4.34. So I'll go here, go to the top view and extrude. So I have already gone to a height of 0.102. So I'll go to a height of 0.102. 10. And I will draw here. If you see, this dimension is 0.83, right? So I will go here and put a tab and say 0.83 and 0.83. And then I will go 4.34, 4.34, 34, and 4.34, right, and say okay. So that's that, and I'll extrude to a height of 101. Okay, 101, and this I will call this as ground 2. Okay, so once I'm done this, you can see that this is through. Okay, so these two bodies have to be merged together. I select first of whichever I want to keep, ground 1, right? So I select it first. Then I would say union. So this is union, and say okay. So I'm left with a single body, which is this ground. But then this is intersecting with this ground, right? Now I want to add a few more things to this. If I go to the drawing, if you go to the top view, you will see that at 45 degrees I have 0.4. Okay, at 45 degrees I have 0.4, right? So I have these lines which are going to the end, right? Now there's something called castellated, in which there may be a via here which may bring this ground contact up, and then when you put a lid on top of it, then there would be a ground on that lid. So basically you put it in a metallic cavity. So that's the idea here, right? So if I want, I can put this, but this is this is not going to hurt you, only on these two pins. But let's see if I can keep it, because the problem here in this is I'm going to chamfer this, right? No. So basically it will go to the end. So let's go ahead and see that. Okay, so if I do a view all, okay, so I need to go here, and I need to go and make a line going this way. Now how would I do that? Okay, to do that, okay, I need this line of a certain width. Okay, so if I go to extrude, and here I am going to make 4 lines, right, going from here to there. So to draw that, okay, so this one, this coordinate, okay, I'll go down and draw this way. So I can do an approximate drawing if I want, right? So what should I be using to draw that? This is a primitive, this is a trace. So cancel this. Let's see, I'm gonna try this trace. And this trace, okay, I will choose a height, and that height is 0.102, correct? Then I'll go here, what it takes to draw a trace. Is it over here? Is it here? What about the width of the trace? So this information, where did it get it from? Oh, width information is over here. Okay, so this says 0.1 mm trace. Is there information in the drawing for that trace? This says this is a chamfer, but no information on the width, is it? Okay, so I'm gonna assume it. There should be information on this one, but there is not. Let's see on this side, is there information? No information. Okay, so there is no information at all. Okay, so let's say 0.2 mm is the trace. Corner type square, doesn't matter. So if I draw this kind of, Has it drawn it? I doubt. This is correct. Okay. It done? Yeah, it did draw it. It did draw it. But what about the height? Height of the trace. Let's go to the modeling sequence. Trace. Width is there. What about the height? So there is no information on the height. Right, so that would not be a right way of drawing this. So I'm just going to delete this trace. Delete. Okay. First of all, I'm going to turn off this base so that I have the visibility. Set invisible. Okay. But then I can't do it, right? Because I need to draw, right? Okay. Let me figure out. Okay, so by the power of pause and magic, I have got these 1, 2, 3, 4 traces going at 45 degrees off to the edge, right? So basically they are going to the edge here. Okay, so we have the ground pedestal ready, right? Now I need to subtract this from that. So let me first make this one visible. Right click and say visible. Okay, so now I have both the bodies available. Now I want to keep both the bodies, right? So I will choose the first one and then control the second one, and I would say chop. So this is chop. So I'm going to keep both the bodies, right? So this one basically is the chopped one, right? So this represents the ground plane, right? And this one the lead frame, right? So I don't want you to get confused. So in the initial itself, I'm going to bring it a metal, right? So I'll go to materials and I will go to select from default libraries. I'll pick up copper. Just goes as CU. That's copper. Add it. And I'm just going to draw copper to this intersection plane. So this is my ground, right? This is at the bottom, it looks like this. At the top, it looks like that. And I now need to construct the pins here, right? And so there are two heights to it. So if you make it invisible, you will see that. This one, I am going to change the transparency maybe. Opacity, isn't it? Let's see if I can change the transparency. It didn't work. Component transparency. Yeah, it did. Okay, so now you can see that this ground has got two heights to it. Okay, the bottom one has gone inside while the top one is bigger, right? So this you can see in the drawing, right? So if you go to the drawing, okay, and let me just show you in the drawing where this is shown. So this is the cross section. So you can see that the bottom is going to be 4.14 and the top is 4.34. That is there. And then you have got these lines which are going to the corner for castellation. So that's what that is about, right? Now what I'm going to do is on top of it I need a cavity, right? So before I build the cavity, what I'll do is first I will build these pins, right? So these pins, okay, there has to be dimensions on these pins also. If they don't give, then I have to assume. Okay, so I guess I have to assume then, right? Okay, so 4.34 is the pedestal, right? So I'll assume that this is going to be 4.4 only, right? And then they are going to bend in, right? Okay, so this is the difficult part, right? This is a difficult part to draw, but I will try it. Okay, so first of all, I am going to go to my drawing, look at the top view, and I will just fit it. So I need to draw my pins here, right? And the bottom portion is going to be straightforward, right? So the bottom portion, so if I go here, the bottom is growing up to 5.24. So basically 5.24 from 6. So if you go to calculator, it says 6 point minus 5.24, 0.76, isn't it? Let's see, does it make sense? 5.24 from 6, that is 0.76 divided by 2. Okay, so they are going to be all 0.38, right? So that's done. Now what about the gaps? What is the pitch? Is there information on pitch? There is no information on the pitch. See in other drawings. Yeah, there is information. The width is 0.3 and the pitch is 0.65, right? And the height is 0.38. So we have to draw those, right? So this is going to be 0.83 onwards, right? 0.383 onwards, right? So that coincides. Actually, this side it is less or more, right? But roughly they should be in place. Okay, why is it important? Well, this is going to be the capacitance between the pins, right? So what I'm going to do is at point 0.3 I'll start, and I will make 0.3 I will start, and then 0.83 I'll start that, right? So let's go ahead and draw these pins. Okay, so you are looking at the top view. I am going to go here and I'm going to say I want to start drawing from 0.83 onwards. Okay, and so that would be the starting point, and then I want to go 0.38 in the height, 0.38 in the height, and I want to go width, correct? And I want A, so that's my pin, and I want to extrude this by 1 2, right? And I will name this as pin 1. Okay, and say done. So that's my pin, right? That's what it is going to look like, right, at the bottom. So I'm going to just repeat it. So basically I will just repeat it on this side. So I will take this pin, I'll say array pattern, and I will do a linear pattern, and I want this difference is around 0.3, so 6 minus 0.6 is 5.4, right? So V is 5.4, right? So no, V is going to be then 6 then. 6 is going that way, so 5.7 then. It goes from the origin then, 5.7. Now 0.38, right? 5.38, right? So 0.8 I have to 0.62, 5.62, correct. Okay, so on this dimension I have only 1, so I don't want to repeat this. So on Z dimension, there's only one. Okay. Correct. Okay. So on Z dimension, only one. And then I need a pitch of 0.65 on this axis. Correct. And I want how many of them? So I need to go and count. 1, 2, 3, 4, 5, 6, 7. 7 of those. 7 into 4 is 28, right? So I am going to put here along this, I want to put 7 of them. Correct? So that's done. It would be nice if I could just do this over here, but it is not possible. So I will name this. Okay, so I'll done this. Done. Okay. So the bottom part of these pins are ready. Correct? Okay. So if you see from the bottom, that will be that. Now, what I want to do is okay, I want to repeat this on the left and right. That is pin 1. So I'm going to do pin 2 on the left side and then replicate on the right side. Right? Now one more thing is there. I need to draw the top level pin, right? Which will be bent out, right? So let me just complete this. So I'm going to go here and draw, right? And I will be drawing from 0.83 here. 0.83. And say I would have a width or height of 0.3 and width of 3.8. So that's a single pin, right? And I will extrude it by this amount and say okay. So I'm repeating the same procedure for the other side. Correct? Okay, so I'm gonna just select this pin. So I'm interested in this pin only. And I'll say modify and then put a pattern. Okay, so linear pattern. So now I want this one to be 7 and this one to be 2. And this pitch would be 0.65 and 5.62. 0.65 and then 5.62. Correct? Is that okay? What happened over here? 0.65 is okay. Oh, 6.2, not 8.2. 6.2. Okay. And I say done. So I have done the lower level of the pins. Now I have to do the top level of the pins. Okay. And it goes this way, that this pin is just going to extend that way. Then these pins are going to bend inwards, right? And they are not parallel. So what I'll do is I'll create this pin over here, copy it over here. For this one I'll copy here. For this one I'll copy here. And then I will mirror them out to the top. Right? So let me see the width again in the drawing. So the top pins The top pins are bent, but is there a dimension on the top pins? No dimensions on the top pins. So you see here, these two are bent inside, these two are bent inside, but these two are bent inside. And this is going to be an approximation, is it? I hate to do approximation. Okay. So I hate to do approximations. Okay, doesn't matter. So this is the most difficult part actually. After that, everything is very easy. Just drawing the pins is the difficult part. Okay, so I don't want to skip any step because then you will be getting stuck. Okay, so I want to do this drawing here. Right, and this is at a height. This is at a certain height, right? So let's check that also if there is information. Is there a information on this gap? Is there anywhere information on this gap? Okay, so it says that this is 0.34 all around. So basically 0.34 from that point. Okay. So this one 0.34 from that one. This is 0.34 and the inner dimensions are 5.3, isn't it? So the lower part is 0.53. So this will be 5.3 and 0.34. 536 minus 0.5, 5.3 is 0.7, 0.35. So this is 0.35 and 0.34. That is going to be 0.69. 0.69 is the height. Okay. 0.69 is the height. 0.69 is the height. Okay, I'm gonna do this. So I'm gonna draw here. Go here. And this one I will keep as 0.102. And at that point, I have to draw a line. Okay, 0.69 from the top. 9. And this dimension I'll keep as 4.14 by 2.93. 0.93. Correct. So let's just do a right click and tab and say I want 0.93 and I want this to be 0.69. Right? And this I want to draw a line like this. Say tab. Okay. Okay, so this one is 0. This is going to be 1. Okay, so this is the line which is kind of not centered because the pins are not centered. That was what I was telling you. Right. Hmm. All way around, same stuff. So left and right pins are not going to be symmetric. Okay. So what I'm going to do is I'm going to move the entire thing to the right. And how much I will see that? Just cancel this out. So there is a measurement of line from here. So I want to check from this corner, how much is it? This is 0.975. This is 0.93, is it? So escape. Okay, so I'm going to go from this corner. 0.83, 0.97. 0.83 and 0.97. 97 minus 0.83 by 2. So I have to move everything 0.07 to the right. So I'll just grab hold of the first pin. Okay, and say modify, translate on the v-axis is 0.07. Okay, so it has moved to the right by 0.07. So now this looks more or less symmetric. Say done. Okay, so this correction will take place automatic, isn't it? So let's still check it. So check from this corner to this 0.9. So 4, 0.90, and this will be also 0.90 roughly. From here, escape, this one, here, .905, correct. So they are done. So similarly, I have to go and modify this guy. This was our first pin, pin 2. Say modify, translate. Now I'm going to translate along V by 0.07. Done. Okay, so now I have symmetrically placed them. Now I want to draw, right? Now I want to draw the top pins. Okay. So to draw the top pins, I'm going to go here and I'm just going to draw them, right? So I'll go to a height of 0.02, sorry. Right? Then I will draw a line somewhere here, is starting at 0.93. And the height is 0.69. Okay, and this is 4.14 roughly. So this side is 0 and this is 4 point. If you can do this part correctly, then you have learned how to do the stuff. Okay, so now we have to draw these pins, correct? So if I was to do 0.3, then a gap, and then 0.3, 0.35 is the gap. right? So let's just do this. I'm going to select this way, and I am going 0.3 to the right. Okay, will this work? Okay, so I have drawn one line over here, correct? And then I need to draw a polyline. This is going to be kind of tricky. Yeah. And this one, sorry about that. I'm going to take out some of the, so not this one. Okay, can I take out later on? Maybe I'll take out later on. Then I need to draw from here 6, 5. Okay, so from here I'm going to go 0.35. Right? Say okay. So there is a line here. Okay, and then I need to draw a polyline. From here I'll go 0.3, 0.3. Let's see if it allows me to do a polyline like that. 0.3. Okay, then I'll come here. There is an issue, but then I'll solve it later on. Okay, so I have done the second one. Now if I repeat this on the right hand side, I mirror them, that's going to work too, right? Because they are exactly mirrors, right? Hmm? Makes sense. Right, so I'll just get rid of them and mirror it. So how about I do 3 of them and then mirror it? Right? Okay, so let's do that. Okay, so I'm going to use some of pause in editing. But let me draw these pins and then I will do that. So that if you miss something, then you have to, figure out yourself. Okay, so I'm going to go 0.35 from here. Or I'll go 0.3 from here. Or 3.2. Because this is all, what you say. This is kind of not specified in the drawing. Okay, from here I will go 0.35. So I will draw a polyline next time. From here, yeah, I will draw a polyline of 0.3. 0.3. Coming here. This is almost straight, right? Okay, so that's the polyline. Okay, fine. So now, center one I'll draw separately. So center one would be the straight extension of it, right? So I'm not going to go into detail of that. So I'm going to use this to get rid of this line. And one line's over here, one of the lines. Okay, so we have 3. And if I extrude 101, Okay, I would be matching the pins like this. They will be at the same level, right? Okay, so we have got 3 pins over here. So I will reflect it to the right. These pins, I'll reflect it to the right and then reflect it to the top. Right? And the center ones I'll draw separately. I guess you understand what I'm doing, right? So done. Okay, you all select this one, say modify and say, okay, so now if you see here, this is kind of something which is not correct. These are okay. The last one is not correct. So I'll go to the modeling sequence, extrude, redraw this. So this is not correct. So these are all correct. You see here? These are all correct. This one is not. I'll take a polyline once again. I'll draw it out again. So maybe my clicking was not correct. So I want this one, this corner, and here I have to with this corner. And then oh come on, doesn't snap. I'll cancel this out. Okay. Oh, there is a small line here also. That's kind of strange. This is going to trouble you. This line is going to trouble you because if you extrude, you can cancel out this line easily. And this one is not canceling. I say done, so maybe that was not there at all. Okay, so these two are looking okay. And these ones I'm going to just extend them out. So I'm not going to worry about this. So I'm going to have only this one. So I'm going to reflect this. So it is going to be. So I'm going to go modify, translate. No, transform, reflect. I'm going to reflect about this axis. Correct? And how many mm I want to reflect it about? So 0.95, 9.905. 0. So half, 3. So let's say this is going to be half of that 0.918 mm, 1.8, 1.82. Calculator. 6 minus 1.82 divided by 2. 0.209. View. Oh, they went the other way. Why they went the other way? Still going the other way. Cancel it out. Okay, so if that is a big issue, I'm gonna draw this again. Okay, so what I'll do is I'll put you on pause, I'll draw all the pins and come back and show you. Okay, so this is a little bit of your tricks which you have to play here. Okay. Okay, so by the virtue of editing and pause, I have this magic done where I have all these 28 pins in here, and all these pins basically are assigned copper, and then the ground pedestal is copper, and then this frame is a lead frame. It's a kind of a epoxy, and we will create another material for that epoxy and assign that material. So now where have we reached? We have done the bottom stack, right, of this bottom stack we have done. Now all you have to do is we have to put one cube like this which will go from 0.203 with a height of 0.597, right? That's all I have to do, right? So let's do that, and this will be done very quickly now. So what you do, go here and you say 0.203, 0.203, that's the height, and then you are going to draw a 6 by 6, correct? And look at its, extrude it. I messed this. Okay, I'll do this again. I'll cancel this. Okay, so I will put one of this over here at 0 0. Other one I'll put at 6 6, right? 6 6, and okay, and I will extrude it by how much? So this is 0.597. Okay, 0.597. So I will extrude it by 0.597. Correct? And that's going to look like this. When you press done, it's going to be covering that, and that's the bottom, right? So basically, this is a graphic issue, but we will fix that, not an issue. Okay, so for example, if you put opacity 200, this is also 100. Okay, so the back side, of course, is like this. Now we need to draw a curvature inside it, so we have to cut it out, right? So to cut it out, what you will do is, let's go to the, so this one I'll keep invisible. Okay, so I'll keep this invisible, and I have to draw another structure, and let's see what that structure is. Okay, so this is basically 0.53. So 6 minus 0.5, 5.3, 6 minus 5.3, and I have to start from that and then extrude out with an angle of 12 degrees. So that's what we are supposed to do. This is at 12 degrees, right? So we have to extrude out with an angle of 12 degrees. So let's do that. So I'll go back here and 5.3. So let me bring up the calculator and look at 6 minus 5.3 divided by 2. Okay, so let me just have a look again. Okay, so the innermost is 5.3, and then let's go up. Then this dimension, outer dimension is 5.554. So I go 12 degrees to do that, and then I have to put this what you call chamfer and rounding of the edge. right? So let's do that. uh, okay. Okay, so I have to do this chamfering, right? So this is a chamfer and this is rounding. So I have to do chamfering, rounding, and then extrude. Okay, so to do that, I am just going to go here and I am going to draw this. So I'm going to fix the height, which is going to be 0.203, right? And then on this, I am going to draw cross section. So 5.3, 0.35, right? So I will go from somewhere here, 0.35 and 0.35, 5 and 0.35. Okay, and this is going to go 5.3, right? 5.3 and 5.3. So this is the lead frame, correct? And then I have to round these corners, right, by 0.5. So for that, you are going to use this, and you click here and you tab here and say 0.5, 0.5 mm. So this is going to be rounded like that, right? Similarly over here, this one is rounded, okay, 0.5 mm. So that's rounded like that. This one is also 0.5 mm. So that's rounded like that. So three corners are rounded, right? And I'm not sure how this is going to behave. So if I chamfer it later on, let's see if I chamfer it later on, what's going to happen. Okay, so I'm going to leave as is, and then I would extrude it out by 0.597. Okay, but then I am going to give it a draft angle by 12 degrees. Okay, so let's see how this shows up. So this is drafting by an angle of 12 degrees. You understand what that drafting is? Right. So it is drafting out at an angle of 12 degrees. Right. So let's say done. Then I am going to chamfer this edge. Right. So if I select this, I want to chamfer this edge. So that will be called chamfer. I'll pick the edge. Okay, and I would chamfer it by 0.4 mm. Okay, so this is chamfered by 0.4 mm. Correct? So this is the hollow portion which is going to open up. Right, so after this, I'm going to say done. So this block has to be subtracted from okay, there is a problem here. So when I was drawing this one, I didn't give it a height. Okay, so this should be 0.203. Okay, now it's okay. So now you will understand. So this is the box which is sitting on the top of this, and then this has to be subtracted from this. It has to be subtracted this one. So I would subtract this out. Oh, okay. This may be because of the drafting, maybe. Okay, let's do an undo on this. So basically, if I draft it and if I chamfer it in advance, there is an issue. Is there an issue of chamfering? So Let's see. I delete this chamfer. Okay, let's see if I can subtract this guy. Okay, so oh, no need. I think it was working. Okay, let's see this again. This model I'll set visible first. Okay, so this model, so this I have to set visible. Okay, so why is it not visible? Something crazy here. So from this model, I want to subtract this one out. Oh, I didn't subtract it. From this model, I have to subtract this one. This one I have to subtract. This one is subtract. Yeah. So after subtraction, this is the QFN which I have made. And then what I'm going to do is I'm going to take this one and I'm going to merge it with this one as a one frame. Right. So here I am going to say union and say OK. Okay. So now this is one piece. Right. And so I have copper contacts, 28 of them, 28 pins, ground pedestal, right? And then I have got these contacts. Now I'll be able to put on top of it, I'll be able to put my IC and then put PON wires here, right? And then below this, I will be able to put my my board, whichever board or laminate which I use, and that will be it. Now if I want to add a lid to this, so I can add a lid also. So I'll have to just do extrude orientation 0.597 plus 0.203 is going to be 0.8, right? So 0.8 is the height, and let's put a lid of 2. 0.8 is the height, and here let's go to the top view. Okay, and let's put a lid on top of it. Right, so I am going to just draw this at that height, 0, 0 to 6, 6. Say OK, and extrude it by 0.2. Okay, so that would be the lid on top of the QFN. Right, so I'm going to say, I'm going to give this a name, a lid. So this is the lid for the QFN, and the lid can be castellated. So what it means is that you can coat this lid with a metal, and then have vias going from top to the ground plane. So basically, it acts like a cavity. So this will protect it from EM radiations or EM pulse or whatever electromagnetic pulse you see. You fry the circuits with this EM pulse, like in the movie Matrix, right? You could everything with the EMP. So that will not happen to your circuit if you surround it with a metal cavity. So that is called castellation, right? Now let me put a transparency on this, what this would look like. So now you can see what this looks like. This looks like your pins, and then inside you have the pedestal. So if I make this one invisible, you can see what is it like, right? So if I put back my opacity to 100%, okay, so this is what the scale drawing of a QFN, and which is a quick pack QFN, and this is the drawing, right? So using this drawing, I converted a 3D model in EM Pro, and I'll be able to put my chip here, and I will be able to put the bond wires, and I'll be able to put the ground underneath. So I'll be able to put a FR4 board or a Durite board underneath, and I'll be able to model the the inductive ground. So this usually is required when you go very high up in frequency, and you have to worry about the transition, RF transition from the chip to the package. So this package modeling is done that way. So I'm going to stop here. So I hope you understand what I wanted to show you. You can take the drawing, 3D drawing, which is like, views, top views, side view, and then the two side views and top view. And using these dimensions, you can convert it into a 3D model. And then using the 3D model, you will be able to get the EM simulation done on it. And with that EM simulation, you will be able to incorporate this EM simulation into your design. So my journey with the design starts with the package, because I want to know where my ground is going to be. I want to know what RF, what inductance it would be seen in input output lines. Without that, I don't design, right? So this is a good practice to do a package first and then design it out. Now there is a glitch, there is a problem here. The problem is, what would be the ultimate size of your chip? Okay, the size of your chip, you should have a rough idea. So if you do a lot of layouts of circuits, you will know that, okay, I'll be able to put LNAPS switch in, let's say, 3 millimeter by 3 millimeter. So the pedestal has to be that 3 millimeter by 3 millimeter, right? So I have put a 4 millimeter by 4 millimeter, and this QFN is 6 millimeter by 6 millimeter. So I'm just going to save it. Okay, and then you can also change the material which you assign. Right, you can assign this to be a ceramic. Okay, so this can be a borosilicate, which is your LTCC process. Usually they are done by HTCC. Then they can also be done by LTCC if this is ceramic. So Barry, for example, is a ceramic thing, and it will go up to almost 100 gigahertz. The packages can go up to 100 gigahertz. While if you use some form of a plastic, right, then the dielectric constant may be high, and these capacitances may be high, and this would cause you problems. Actually, the problem of parasitics is, if you can model it out when you are basically designing a transition, you should be able to model it out. Okay, so that's the only thing in high frequency design. So I'm going to stop here. Thanks a lot. Thank you.